Welcome to another session of Snowflake. Today we'll look at the different types of Snowflake caching. Snowflake, as you know, supports different types of caching, and that is what makes it, one of the unique cloud warehouses available in market today. So there are three types of different caching mechanisms. There is a metadata cache, there is a result cache, and there is a warehouse cache. We'll look at all of these one by one. But before that, let's look at what really is caching and how does it help. Caching is basically the Snowflake's way of getting the query results faster. Okay, and not just Snowflake, for that matter, any database or any warehouse, they have some kind of caching mechanism through which it can help the queries to perform better. And how does it help? It is not the query execution is faster. It is more of the query results are actually stored in some cache based on some queries which have been fired previously. So if you have fired a query and you have already taken the result, or if you have already seen the result, what the database does is it will store that into a cache so that if the user comes back and fires the query again, the result is available from the cache directly. It doesn't have to process this. That is what caching is. Okay. And Snowflake has done it at different levels so that it makes the fetching of the result much faster than compared to a normal query execution. So what happens when a query is first executed? Like let's say you are doing a simple query. Okay, let's say you are doing a select count star from a table. Now this is a query where you are trying to get the stats of a table. Okay, count star. For this, Snowflake has the metadata cache available with it. The query does not really go and get executed on a virtual warehouse. The result is actually stored within the metadata cache, right? It is same to when if you are into the Snowflake console or you are into the web UI and you hover your mouse on the table, you can see the number of records in the table. You can see the size of the table, right? So this is coming from the metadata cache. So if you fire a query like a count star on a table, it is not going to execute it. It will directly give you the result from the metadata cache, and this is blazing fast, right? However big the size of the table is, however the number of columns are there in that table, you are going to get the result immediately. And if you observe, if you have a warehouse in a suspended state, it will not get started because it is not actually using the warehouse, right? This is the first type of caching, which is the metadata cache. It is handled by the cloud services layer, right? The cloud services layer that we have already seen. Now if you're querying which is not a count star, let's say you are trying to do a select star from a table. Okay, this is where the query will first go and see if the result is already available in a result cache. Now if a user has already fired this query in the morning, let's say 10 o'clock, and the query got executed, it used the warehouse to compute, got the result after say 10 seconds. Now at 11 o'clock, if the user again wants to go back and see the query and he fires this, the query does not get actually executed. The result is fetched from the result cache because it is already available within Snowflake. Okay, this is the second type of caching. So who can use this cache? It can be the same user or it can be someone with the same role. Okay, same kind of a privileges, same kind of access mechanism. They can go and fetch this result from this cache. So you don't have to again execute the query, wait for the query to come back and give the result, or even you don't have to spend money on the spinning of the warehouse. So this is the result cache. Also, if you already fired the query, you don't even need to go and fire the query again, right? If you go to the query history tab, if you click on the query, you will find the query result there. There is a button there for export results or get the results. You can do it from there also. So you don't even need to fire the query. But even if you fire the query, it's not going to execute or it's not going to use any compute credits. You'll directly get the result from the result cache. Okay. Now this is only if if the data is not changed. Okay. If the data has changed, then obviously the cache needs to be changed. I mean, you won't get the result from the cache because the data has changed and it is available for 24 hours. So within 24 hours only you have to use this. Now the third is the warehouse cache. Now suppose you have fired a query, it's a select star, and you cannot get that data from metadata cache because it's a select star or it's a join. and it has not been used in the, it is not there available in the result cache. So even the warehouse which is used for computing this query, it has some, caching with it. It has some SSDs with it. So it will try to retrieve that data from there. Maybe there's some part of the query result. It will try to retrieve it from there. So how Snowflake query execution works is, first it will check the metadata cache. If it is, queries related to metadata. If it is not, it will go to result cache. If the query, if the data has changed or it's a different query, then finally it will look for the warehouse cache. Now warehouse cache is available only till the warehouse is in a running state. The moment you suspend the warehouse, this caching is lost. Okay, and that is why we always say that, right? You can have your auto suspend on, but suppose you are running some queries which uses the warehouse, which uses the warehouse cache, then you have to rethink about this strategy of suspending your warehouse. Okay, there is a trade-off between that. Either you get the cache or you either get the, you save on the credits. So this warehouse cache is only available till the warehouse is running. Okay. Now, what if the results cannot be fetched from this warehouse cache also? In this case, right? In this case, when the metadata cache is not useful, result cache is not useful, warehouse cache is not useful, then the last option is where the Snowflake will look for the data on the actual disk, right? So that is the actual fetching of data from the disk. Now, suppose you are running a query for the very first time, it is not there in the result cache, there is nothing in the warehouse cache. That is the time it will go and look for the disk. But for all the other queries, right, all this caching is there, and this is what makes it so faster, right? Even the metadata cache, right, getting a count star directly by just hovering the mouse over the table, this is still not available with many other, databases or warehouses. So this is what makes Snowflake really fast. The caching, the way it is done, right, it is, it can help you to get better performance or faster query results. So all this makes Snowflake really unique. You can go ahead and explore this. You can play around with the, metadata cache. You can have your warehouse cluster suspended and see whether it is really being used or not. And that is how you'll come to know whether the warehouse is being used. Also, another thing you can do is, when you go into your query history, click on the query ID, go to the query profile. And if you, when you look at the query profile, you'll understand whether the cache is being used or not. You will get those, details there. Another way is, again, in your query history, you will see from where the results are being fetched. You'll see the, warehouse being used or not. You will see how much records are being, fetched or not, right? So these are all the ways to understand how, whether the Snowflake is using cache or it is actually using the compute engine. So go back and explore this on the console, on the UI, and try to play around with this to understand it in a better way. But when you're architecting something, using Snowflake, keep in mind about the warehouse cache. Keep in mind, right, what is the kind of load, what is the frequency of the query before having an auto suspend of 5 minutes or 10 minutes, right? It's a trade-off, as I said. You'll have to consider all these points when you're building the solution in Snowflake.